Welcome to the Inductive Statistics course from the International Business School of Hanze-IBS-Inductive of Applied Sciences. Today we are going to learn what is the standard error, the standard error for infinite population and standard error for finite population. And we know that when your sample size increases, the dispersion of your sample means will decrease. And that means your standard error will also decrease. That is why we say the larger sample size, the more representative your sample of your population, and the smaller standard error you will get. Suppose we have 3 numbers, and each of the number can be chosen 2 times. And each time we randomly select 2 numbers. How many combinations we can have? We can have many combinations like this. We can choose 1, 2, 2, 1, 1, 1, 2, 3, and go on. And for each selected samples, we calculate the mean. We call this as the sampled means. And we know that the mean for 1 and 2 will be 1.5. The mean for 1 and 1, that will be 1. And you can find, when you calculate that, the most frequent occurred mean is 2. So this is the mode. And if you use the bell-shaped curves to visualize it, you can find it is also the mean of the sample dispersions. And 1.5 is besides that, and 1 or 3 only occurred once. So we say the mean of your sample distribution is the mean of your population. And the standard deviation of your sample means, we call this as the standard error. And it comes from the standard deviation of your population divided by the square root of your sample size. If we know the mean, we know the standard error. Actually, you know, now standard error is another kind of standard deviation, but it is only for your sample means. And then we can calculate the z-score. Previously, we have learned this equation to calculate the z-score. Now we can revise that to use this. X bar, that is your sample mean, minus the population mean, and divided by the standard error. And then you can get your z-score. And let's look at one question. On page 322, it is question 636. On average, 110 telephones per day are being returned. The standard deviation is 64. Mr. Answer decided that unless he is at least 80% certain that on average, no more than 120 phones per day will be returned during the next 48 days, he will order the process overhauled. Will the overhaul be ordered? Overhaul means you need to check it. And we translate this word into different languages. In this case, you know the sample size is 48 because you only pick up the next 48 days for study. You know the population mean is 110. Per day, 110 telephones will be returned for overhaul. And the standard deviation for these 110 telephones will be 64. The probability is 80%. That means what will be the probability that we have the data less than 120? If the probability is larger than 80%, we do not need to order the overhaul. Now first we need to calculate the standard error. It comes from the standard deviation of the population, 64, divided by the square root of the sample size. So the square root of 48. And there we get the standard error, 9.238. After we know the standard error, we can continue with the z-score. The z-score comes from 120, this is our individual value, minus the population mean, 110, and divided by the standard error, 9.238, which we have just calculated. and we get the z-score 1.08. And when we check the table A1, we get the probability 35.99. But don't forget, this probability only means from 110 to 120. So only means this part, not this part. And this is 35.99% of the data. We still need to add 0.5%. 0.5, that means 50%. So later we get 85.99%. That means Mr. Anson is 85.99%, that he will get less than 120 phones per day. That means he doesn't need to order the overhaul. After knowing how to calculate the standard error for the infinite population, we also need to know what will be that for the finite population. For the finite population means most of the time you know the exact number of your population and your sample size is quite large, and then you need to expand your equation into this. We call this as an FPN, finite population multiplier. And in which condition you need to use this finite population multiplier? When your sample size divided by the population size is larger or equals 0.05, and then you need to use this equation. In the other cases, you just use the infinite population, use these equations. Let's go on to look at one question. Food Place has 145 supermarkets and has been bought out by a larger supermarket chain. Before the deal is finalized, the larger chain looked at the financial records for 36 of Food Place's supermarkets. The standard deviation is $1,200. What is the probability that the same sample mean for the 36 stores will fall within 200 of the actual mean? In this question, you have already know the sample size is 36 because you only look at 36 Food Places supermarkets. And the population size is 145 because in total, Food Place has got 145 supermarkets. And the population standard deviation is 1,200. And first, we need to check whether we need to use the FPN. And we found when we used the sample size divided by the population size, we got 0.248, which is larger than 0.05. So we can continue to use FPN. And then we calculate our standard error. We expand the equation by using 145 minus 36 divided by 145 minus 1. And then square root it. And then we get our standard error is 174. After you notice your standard error, you can calculate the z-score. And in this case, we don't know the x-bar, we don't know the population mean, the mu. But the question tells us about the difference between x-bar and mu. That will be $200 because it says will fall within $200 of the actual mean. Within $200 of the actual mean means it either plus or minus 200. And then you get x-bar minus mu should equals 200 and divided by the standard error, 174. You get your z-score. And then you check table A1, you get your probability 37.49. But don't forget, 37.49% only means this part or this part. So you need to double it. Then you get 74.98%. Then that means 74.98% of the data will lie between plus and minus $200 of the actual mean. This is what we have learned today. The standard error, the the standard error for infinite and finite population. If you want to know more video-based explanations, you can go to YouTube to search the keywords Hanze-IBS-Inductive statistics, or you can go directly to Blackboard, STA2 assignments, and find the folder video explanations. Thanks for watching.